at the federal level departments and agencies that either fund or support or conduct research or involved in science policy in different ways. So that was a really interesting office to both contribute to policy advice, but also development and coordination and implementation of science and technology policy across the entire government. And so for my own focus, it was originally more around medical countermeasures and public health preparedness issues, but just with the nature of that office, really interesting opportunities to work more on broader biotechnology issues, innovation, emerging technology, commercialization and technology development issues, STEM education. So a broad set of activities. Next slide, please. So I just wanted to highlight a couple points and things to consider, you know, from my work and experience. We may have skipped one slide, but if it's not there, it's okay. Yeah, so there's a whole science of science policy, and for those who really want to, you know, dissect different areas and issues to focus on. But I just kind of put this in two categories as you think about opportunities to work on policy issues. So one is kind of policy that directly impacts science and research and development and work you can do in that space. And obviously, whether it's White House or Congress, state and local agencies that are setting priorities and funding. So whether, you know, we've had things like the Precision Medicine Initiative or Brain Initiative, or focusing on advanced manufacturing, or physics and astronomy initiative. So obviously really drives where research is going to go, sometimes for an extended period of time, to workforce and training, to building, you know, new labs and facilities. That's going to drive the future of research, to the regulatory environment, which obviously shapes new technologies, innovation. Another, again, simplified, you know, perspective, but to think about is science informing policy. So broad science informing a broad range of public policies, and having science-based policy, which we hear a lot about, and whether that's through, you know, bringing a scientific perspective to analysis and implementation of policy, to evaluating it, where there are unintended consequences, where the outcomes what we expected. And so that's obviously an important piece, but also important to keep in mind for a policymaker's perspective. The science piece for us is a critical element, but also there's, you know, economic impacts, you know, societal norms, ethics, a range of other issues to consider in policymaking. And so on the last slide, I just wanted to highlight, as I was saying, just from my experience, particularly at Office of Science Technology Policy, just thinking about different aspects of science policy and politics, and also science advocacy and science policy, particularly around policy analysis. So as you think about politics, which obviously has major impacts on policy development, but, you know, at its purest level, I suppose it's really more about, you know, power and influence, and who's in control and can implement their agenda, and brings in the politics and lobbying and advocacy aspects. Whereas the policy process, you can think about, again, in its more purest form, is more about development, analysis, and implementation of policy and evaluation of that, and what the impacts were. And obviously, politics can have varying degrees of impact. Right now, it seems like, you know, significant. But, you know, those are important considerations as you think about where, if you're interested in policy, science policy, where you want to work in an organization and an agency, and depending on your role and where you sit in that organization, there's more or less of a political aspect to that. And that's not only true for the government, but in academia and in industry and other organizations. So for many agencies, you know, by and large, most of the policymaking process isn't directly day-to-day dealing with political issues, but certainly parts of the agency will. So just an important thing to think about in doing science policy. And then also some distinctions between science advocacy and science policy and the analysis of policy. Obviously, both important areas, but to think about if you're more interested in advocating for particular scientific issues, or for science itself, or more in bringing science to inform public policy decision-making and analysis. So just a couple of quick things to think through. So thank you again. Look forward to the discussion.
Thanks, Scott. Between each panelist, we'll allow just one quick question that's directly related to their presentation, and then we'll allow like an open form at the end. So if anyone has a question right now, they can do their raise hand function, and we'll just call on the first person. Okay. All right, we will move on then. I'll be introducing our second speaker, Mike Fisher. So let's go back to here. So Mike also has a PhD, but he's currently a senior fellow at the Federation of American Scientists. His work currently focuses across many issues that involve both science and technology in the policy landscape. He currently co-leads the Congressional Science Policy Initiative, which aims to help more readily connect science and technology expertise with the legislative branch. Prior to joining the Federation of American Scientists, Mike served as a field director for a congressional campaign, a STEM educator at Liberty Science Center, and developed technical expertise in infectious disease research, biofuels, synthetic biology, protein engineering, and molecular biology. So with that, Mike, would you like to share your slides, or do you want me to share them for you as well?
Yeah, I should be able to share these. Let me know if it's not working.
I think my other slides are open. Can you try this now?
Yeah, I guess if you would share my slides, that would be great. There's some kind of security permissions thing going on.
Oh, okay. That's unfortunate, but good thing we have your slides then. Cool. Here are your slides, and should I start on the second slide for you?
This one's okay for now. Yeah, thank you very much, Wesley. I'm really happy to be a part of this conversation. So yeah, as Wesley mentioned, my path into science policy, I was mainly a researcher, graduate school, a couple postdocs, and then my main launching pad into science policy was working on a congressional campaign in 2018, which then led me to my position currently with the Federation of American Scientists. So as a graduate student and a postdoc, I'd always been involved with different graduate student and postdoc groups. So I kind of had an organizing experience on the professional side of things. And then it wasn't really until I got into activism and then the campaign in 2018 where it took more of a political bent. Next slide, please. And so I helped to lead the Congressional Science Policy Initiative at FAS, which is a nonpartisan effort to facilitate the engagement of scientists, engineers, technologists, and other experts with the legislative branch to help produce evidence-based public policy. Next slide, please. So one of the reasons why we're doing this is because there isn't as much science and technology capacity in Congress as we'd like. Legislators tend to be generalists, and only 17 of the 535 members of Congress have a background in science and technology. And to compound that, policymakers and their staffs have been cut over time, both in personal offices and on committees, have limited bandwidth for engaging with science and technology. And then also legislative branch science and technology resources, like at the Government Accountability Office or the Congressional Research Service, which are agencies that are mandated to serve Congress, those resources are also limited. And so on the left of the slide, these are the titles of several studies that have come out just within the last year or so that have really cataloged where the gaps are and also what the needs of Congress are. Next slide, please. And so our program, we have like three main functions that just try to help with this problem. One is to help enrich congressional hearings with science. Another is to help provide technical assistance on pieces of legislation. And then the third is to help organize councils of scientists and engineers who can serve either congressional offices or congressional committees. Next slide, please. And so what's this idea about enriching congressional hearings with science? So both the Senate and the House hold committee hearings. There are hearings just like the ones that were just to confirm Judge Barrett, but for all different kinds of topics. And so these are forums where members of Congress conduct oversight of both the executive branch, but also corporate practices, like CEO of Facebook, Mark Zuckerberg, will have to go to hearings. Members of Congress will question witnesses, learn about science and technology, and also develop policy ideas. And so what we do at CISP is we track this activity, and when key hearings are announced, we reach out to the CISP community for questions and ideas that members of Congress might raise during these hearings. And so we collate that, and we then communicate that for use by Congress, which promotes a rich discussion of the issues. And then we also post everything on a website. Next slide, please. And so far, since we launched this program in March, we've worked on more than 70 hearings, and we've sent over more than 730 questions to Congress. And a decent number of these are actually raised during hearings. This community is now about 880 people strong. And basically anyone who's committed to an evidence-based approach is welcome to join, but 740 of them are scientists, engineers, technologists. And then we also work with partners such as the National Science Policy Network, reach out with social media, and also use targeted engagements where if we know there's going to be a hearing about internet privacy, for example, we'll just kind of cold email a number of people who have written recently about it or are very much experts on that particular topic. Next slide, please. And since we've done all this work with Congress, we then get opportunities to help with pieces of legislation. So, we build these trusted relationships with congressional offices, and sometimes we are then asked to provide this technical assistance on bills. And so when those opportunities come up, we again crowdsource this feedback from the CISP community and communicate that to Congress, which again helps to strengthen the policy process when you have feedback from this wider audience that may not be involved otherwise. And a good example of that was the Engineering, Biology, Research and Development Act, which passed the House. It hasn't been brought up in the Senate, but it was a bipartisan bill that passed the House unanimously. Next slide, please. And so then this last idea is to build councils of scientists and engineers for members of Congress. So just like the president has a presidential science and technology council, wouldn't it be great if each individual member had access to an analogous science and technology council? So our proof of principle for this was organizing this COVID-19 rapid response task force, where we brought together over 60 folks with various different areas of expertise on pandemic response and infectious disease research. And we have made those people available to members of Congress. And so just one example, the group briefed Representative Bill Foster on the potential of monoclonal antibody treatments to counter COVID-19, which gave him and his colleagues, when he passed that information on, a very realistic evaluation of kind of the status of monoclonal antibody treatments for coronavirus. This program was also made available to senators and policymakers in state legislatures, and 7 different states legislatures took advantage of that. Next slide, please. And so again, the 3 main things I'm involved with are enriching congressional hearings with science, providing technical assistance on bills, and forming these councils of scientists and engineers. Next slide, please. And if you'd like to be involved, this is kind of the recruitment call. Please go to fas.org/Congress. We're basically looking for anybody who really believes in data-driven policy to join the community, and there are weekly calls to action. And thank you very much. I'm happy to take any questions.
Well, thank you for that, Mike. So one question before we moved on to the next panelist, and then again, an open forum at the end. So if you want to ask a quick question, I think we have the raise hand function here while I prep the next set of slides. All right, if not, I will introduce our final speaker. And just a quick reminder, as Jimin and King have mentioned in the chat, if you have any questions and you're shy to speak up, you can always use the Slido. So go to Slido, slido.com for anyone that just joined. And on the website, there should be a hashtag or group thing. Yes, Jimin's gonna send it in. And then you can populate questions there and we'll ask them on your behalf at the end. So with that, I'm going to introduce our final speaker. All right. So our last speaker of the night is going to be Chris Schaffer. He's associate professor in the Biomedical Engineering Department at Cornell University. He went to UF for his undergraduate degree and then got his PhD from Harvard, studying physics at both institutions. He moved from all the way to the east to the west to go to UC San Diego to work as a postdoc in the David Kleinfeld Neuroscience Lab. Currently, he now jointly runs a lab with Professor Nozomi Nishimura at Cornell, where they develop advanced optical techniques that enable quantitative imaging and targeted manipulation of individual cells in the central nervous system of rodents, and uses such tools to construct a microscopic scale understanding of normal and disease state physiological processes in the brain. One area of current focus is understanding the role of brain-blood flow disruptions in the progression of Alzheimer's disease. Beyond this, Chris is also active in developing novel education strategies to teach science as a dynamic process for discovery that are used in outreach settings in middle and high school science classes, as well as in college-level courses and international student exchange programs. Chris also has a strong interest in science policy and spent a year in Washington, D.C. as a science policy fellow in the office of Senator Ed Markey. You might have heard his name come up recently. He continues to be active in policy, including through a science policy course he teaches. Chris is an accomplished surfer, having ridden waves all over the world and surfed some big wave spots, including greater than 20-foot waves at Todos Santos, Mexico. So with that, Chris doesn't have any slides, so I will just let him talk to the open forum. And thank you for joining us, Chris.
Great. Thank you for the introduction, Wesley, and thank you to this organization for the opportunity to come and talk. I sent a couple of last-minute slides, Wesley, just a couple of minutes ago. I don't need them yet, but I'll show them in just a minute. So I thought I'd take a couple of minutes first just to talk about my own interaction, my own career in science policy, and then I really wanted to spend time on two issues. One is, I think, explaining some of the low-level mistakes that I think many scientists make in interacting with policymaking world. And I learned about these during my time in policy, where I made them. And then second, I wanted to quickly touch on the AAAS Science and Technology Policy Fellowship, just to make sure that people here were aware and knew about that program. So I've had a fairly traditional academic career, undergraduate degree, straight to PhD, to postdoc, to faculty position. But all along the way, I was always sort of like a armchair policy wonk. Some people yell at the decisions that coaches make during football games from the sidelines while they're watching TV. Well, I would read op-eds or New York Times and scream at the paper in the morning about what I thought was not the right thing to do in terms of policy choices. So I've long been kind of interested in policy. But there was never really a time in my career where I felt like it made sense to just go devote and spend time on it. until my first sabbatical came up. That's now almost 10 years ago. But I applied for and won one of these fellowships that are run by the American Association for the Advancement of Science. These fellowships have been around for almost 50 years. And their role is very similar to the program that Mike was talking about. The goal is to try to bring more scientific expertise to policymakers that are making decisions. The approach of the AAAS fellowship is a little different. It takes a smaller cohort of people, and then the idea is to embed them as science advisors among policymakers. So for these fellowships, there's there's between 30 and 40 of these fellowships that are funded by various scientific societies. And those fellowships place someone in Congress. So you would work as an advisor for a member of the House, for a member of the Senate, or you could work as an advisor on one of the committees in the House or the Senate. There's another roughly 250 or so of these same fellowships that are funded by the various federal agencies. And for those fellowships, your placement would be in the policy shop in some branch or some part of a federal agency. So you could be, for example, working in the NIH director's office, setting policy around strategies to improve funding of grants from faculty of color, or policies for thinking about how should NIH align its various funding around pain to try to better address the opioid crisis, questions like that. Could be placed in the Justice Department, working on questions about what kind of scientific information should be used in federal courts or that prosecutors should be willing to use in federal courts. Anyway, I think these fellowships are sort of the ticket into policy. If you have a PhD and you want to, and this is a direction you want to go, I find it pretty amazing in a random bar in DuPont Circle in Washington, D.C., which is kind of a hub where a lot of lobbyists and things like that are. In a non-pandemic time, you could go in and announce yourself as an American Association for the Advancement Science and Technology Policy Fellow. And between 1/4 of the people who are in that room would know what that means. And that tells you sort of how much cachet that this particular fellowship carries around in Washington. It's something that's been around for many years, run by AAAS, and it's a very, I guess, a well-worn path for PhD level scientists who are interested in influencing or having careers in science policy. So anyway, I joined Representative Ed Markey's office under this fellowship. I was in his office a few months when Secretary Clinton stepped down from Secretary of State. And at that time, then Senator John Kerry from Massachusetts became Secretary of State, which opened up a special election in the state of Massachusetts, which Markey ran for and won. And then I actually moved with him to the Senate that year. So I saw the House. I saw a bit of a crazy kind of special election campaign, and then the Senate side of things. I worked on a broad variety of different issues. As Scott said at the beginning, policy makers are generalists and are spread pretty thin. To give you a sense of how thin that is, in Senator Markey's office, when I was leaving it, there were 7 of us on the policy side of the office. So there were 7 people who were the senator's advisor for everything, all science policy, all everything policy, international, domestic, interactions with the government, interactions with everybody else. So you're definitely spread very thin. Some of the science policy things I worked on were like, how can we make nuclear reactors safer? What are the appropriate regulations around the use of nuclear power? What are the appropriate safeguards to keep firewalls between military and civilian use of nuclear energy to prevent bleed through of technologies or even motives? The Boston Marathon bombing happened the year I was in Congress, and it actually happened in parts of the sort of chase that happened afterwards were in Markey's district. And Markey was running for an open Senate seat at the time. So One thing that I think is important to understand about policy, and especially the closer you get to politics, I think this is more true, is that everything can change on a dime. So one morning I woke up and I was working on nuclear weapons. Sometime mid-morning, I was working on terrorist watch lists, pressure cooker bombs, immigration policy, and all kinds of other things, and spent almost a month working on almost nothing but that. So you are often reactive in the world of policymaking. But you're also spread thin. I was the foreign policy lead for the office, mostly because they figure Markey could get that kind of stuff right, so it didn't really matter if he got a little bit of bad advice from a junior person in the office. So you know, you worked on many different things. I just want to finish with kind of a few lessons that at least I felt like I took away from this time spent in Washington, and it really came from the fact that, you know, so working on the Hill, you work a lot, but for, you know, 6 hours a day, most days, you're meeting with people who, you know, want to influence one thing or another that the government does. Sometimes somebody inside the government, oftentimes somebody outside the government. And our government is remarkably open. I have to say, I was surprised. I don't know why I should have been, but over the course of a year, I never saw Senator Markey's office turn down a meeting for anybody. Every single person that wanted a meeting got a meeting. And it's pretty remarkable. So anyway, if you were a scientist and you wanted a meeting for that year, you got me because I was the science policy advisor. So I met with hundreds and hundreds of scientists over the course of the year that I spent in DC, and they were all down there trying to do the same thing. They want to somehow improve communication between science, between, you know, what they're doing and government. But I have to, and at the beginning, this felt great. Like these felt like they were my peeps, you know, would come in and I'd actually enjoy the conversations a fair bit because they would, you know, start out with things that I felt comfortable with, talking about science and that kind of thing. But I later realized as I got to the end that these conversations were terribly harmful. I would say that the typical effect of an average scientist going and talking to a member of Congress or their staff is somewhere between neutral and damaging. It's probably neutral if you just kind of tune them out for 20 or 30 minutes. And I think it's often damaging if you listen to some of the things scientists are saying. So I sort of summarize this into like the 4 sins and maybe what you can do better. So Wesley, if we could show that slide, or I can share my screen. Perfect. So 4 mistakes that I often saw people make that I think really destroy the chances of creating a meaningful dialogue between scientists and policymakers. So the first is this naive assumption that scientific fact is policy prescriptive. It's not. That's not what democracy is. That's not how our government operates in this country. There are all kinds of pieces of information that are appropriately used to formulate policy in a democracy. They incorporate public opinion. It's the gut instinct of the elected official. It's the way we've always been doing it. There's things written down in 2,000-year-old books that play a role. I think scientific facts should be an integral part of the information that's used to formulate policy. But to be honest, there were often times, I think, where the scientists and the scientific ideas were a little bit left out of some rounds of the policymaking process. And honestly, it's because so many times the scientists that would come in would have this scientific fact as policy prescriptive. So fact A, fact B, so now obviously you have to do what I say. And so nobody wants to have a conversation like that. And so scientists are left aside. So the fix to this is a lot of work. It means that you have to engage in an informed discussion around the issue that you want to advance. And information here doesn't mean you've figured out the sort of cleverest argument to shoot down what you think is the objection. That's not the goal. The informed discussion meaning you really have to learn and understand the perspective and the reasoning of your opponents. And you have to be ready to come and engage, not necessarily defeat, come and engage around that perspective. the ability to cleanly define what you are at odds over so that you can start negotiating and fighting about it, and to clearly define the things that you are not at odds over so that you can move past them is critical. And if the way that discussion starts is with scientific facts that are policy prescriptive and you have to do what I say, it's never going to go anywhere. A second major problem is I see too many scientists come in with their hands out around appropriation season asking for STEM funding. More STEM funding, more STEM funding, more STEM funding. And as Scott said at the very beginning, that is a relatively narrow aspect of what we would call science policy. That's kind of the policy for science world. How should we fund science? How should we regulate science? How should we educate to develop a scientific workforce that advances the goals of the nation? There's a much broader set of questions where we're trying to make policy decisions or where the government is trying to make policy decisions and would benefit from high quality scientific advice. And I think when you only show up for the money and you're not there to help when there's a need for your knowledge, you're dealing with very smart people in government, and they remember who has been there to help solve their problems, help provide good advice. Maybe the recommendations of someone who's thoroughly engaged like that on funding is something you would consider more seriously. So I think it's important, regardless. It's important if you're interested in science policy to think about science policy broadly, and this could start very local. Like, what is STEM education like in your school district, in Rochester, or in your home school district? Who's on the school board? Who made the decisions? I think we could all make things much better in this country if we focus a bit on school boards. A third thing is, remarkably, scientists throwing each other under the bus, often in the scramble for funding. In the space of 1 week, I had a delegation of high energy physicists, followed by a delegation of plasma physicists come to me in Markey's office, both with a letter that said the same thing. The letter said, we realize that funding in the Office of Science is going to be tight this year. So we know the top line budget can't go up, but what we do is important. And let me tell you where you can get the money. It's from those other folks. And look, it is not the role of Congress and members of Congress to be peer reviewers to decide what science should be advanced and what shouldn't. We shouldn't be outsourcing peer review to our government. Instead, we should be bragging about the peer review system that we've developed in this country. It's the absolute worst way to distribute scarce resources, except anything else that anybody's come up with. So it's the best we have. It's being emulated around the world. So when we talk about science and science funding, we should be talking about support for capital S science, the enterprise of science, for which your work is an example, and the resources that are allocated to capital S science are distributed between federal agencies, ultimately through it's something similar to a peer review process, and certainly within federal agencies distributed by a peer review process. And the last thing, and then I'll be done, Wesley. And this is going to be something that I think is a little hard to hear as a junior scientist, but most of the time when scientists were coming to me and not happy about how things were going, it was a very personally centered perspective on that. Some of them are things like career prospects for young scientists are challenging. It's very difficult getting a first grant as a PI. Others were, I'll give you one example where I almost leapt across the table and smacked this individual. But I had a respected faculty member at of an institution in along a river that starts with a C. It starts with an H. Anyway, he came and he said, funding rates are really hard right now. So few grants are getting funded. I have to write so many grants just to get enough money to support my lab. And it's just taken the joy out of being a scientist for me. And and he wanted to know if I guess I could make him happy again. I'm not sure what the request was. I mean, so I honestly said, I said, you realize that the federal government doesn't fund science in order to provide 6-figure salaries to people with job descriptions that say, do what you think is important so that you can fucking be happy. That's not what this is about. So I think it's critical to remember when we're thinking about the problems that we're having in executing the science that we want to do, that we don't need to think about solving those problems as just another constituency where we need to get our problems solved. Instead, we need to pivot the whole thing and talk about the idea that scientists play a critical role to fulfill in society, in discovering new knowledge about improving our understanding of how the universe works, and developing technology that gives us increased control over our fate. And in order to fulfill that role in society, there are certain resources that we need. And that is why we're arguing for support from federal governments, from other funding agencies. It's so that we can fulfill our role in society. In over a year, I didn't have a single scientist that sort of came forward with something like that. It was always about how the state of things at the time had impacted them personally and their ability to conduct science. And that's not the only perspective that I think is helpful. Next slide, Wesley. I just wanted to show, this is the, so I just took a screenshot of the top of the AAAS Science and Technology Policy Fellowships. That picture there is last year's class. So there's quite a few of these fellows. There's an excellent sort of cohort among the fellows between years, and in a given year forms a fantastic alumni network that I draw on regularly, both for advice on things, for networking connections, as well as guest speakers in my classes on policy and stuff like that. So sorry for taking a little bit longer than I intended, but that's it. I'd be happy to take any questions.
Well, thanks, Chris. So at this point, we'll just transition into the open forum. So we'll go to Slido and read the most popular questions or that people had, and yeah. So maybe we can rotate between Jimin, myself, and everyone to kind of just moderate the questions, and I can lead us off. So the most popular question we have on Slido right now is, you all have science training backgrounds. What additional training in politics/policy did you have? How did you merge the two? And any of you can take that or jump in on top of each other.
I'll take a first stab. One thing, in addition to skills, I think you also, you have to imagine yourself in the role. And one of the things that I was most worried about is that, I was going to go down to this sort of policy making world, and I just wasn't going to get the ethos or the values or the kind of culture of the place, and then just wouldn't fit in a way where I could be productive or where I could learn. But I have to say, I think that there is, at least in the kind of, I don't know, commitment and culture aspect, there's a lot of similarities between people who choose to go into science and choose to go into policy. In both science and policy, I think people who are really happy tend to be people who are process motivated rather than results motivated. Think about yourself as a scientist. If you were happy only on the days when you had a result and you understood and you knew something new about the world, what, you're happy. If you're really good, you're happy one day a year. That would be pretty miserable. But I think most people who really enjoy doing science, being a scientist, they enjoy the process of science, where you come in every day and you read some papers, learn something, do experiments that don't make sense, wrestle with the unknown, and you like that process of just trying to advance the boundary of knowledge. And then you have what I think you could only describe as a faith in the enterprise of science as a whole, where a whole bunch of scientists competing and cooperating in this ecosystem of science over time improves the human condition. I think people who go into policy and politics have in this country, have a very similar kind of perspective. You're not going in for the short-term win. If the only day you're happy is the day that your bill gets passed or your legal brief, or your lawsuit is won or something like that, you're not going to be happy very often. Instead, I tend to see people enjoying the process of engaging in wrestling with and arguing about key ideas that shape our society and trying to advance the perspective that you think is the right way to move forward. And that's coupled with a faith in the system of democracy, where over time there is, as Martin Luther King said, that while the arc of the moral universe is long, it bends towards justice. There's this idea that over time, democratic institutions have improved the human condition. So anyway, I'm sorry, this is kind of a long answer. I know you were asking about skills, but I think even more important than skills, the motivations and perspective and willingness to commit to a long-term goal that makes things better. Scientists just fit right in the policy environment from my perspective.
Yeah, and I can just chime in a little bit. I agree there's some similarities, particularly with policy analysis, I think, which is more what I focused on, is just, you know, if you bring those same kind of analytical skills and approach to looking at a policy problem and trying to provide some recommendations. And I think, you know, as I mentioned, as far as skills or experience, I took advantage of having a school of public policy where I was doing my Ph.D. work to not only take some courses, but then to get more involved in working on policy issues and policy memos and to kind of blend some of that. So wherever you can take advantage of that kind of experience, I think it's helpful.
And then, you know, for me, one of my first exposures to science policy was a seminar series that was going on in graduate school, and it wasn't attached to my department or anything. I just noticed that it was being advertised and I started going. It was for, I think, biological security and global health, something like that. And just by going to that seminar series, I met a bunch of people who were also interested in these general things. And that was always kind of a seed in my mind. And then certainly as I got more into it and working with various activist groups and the campaign, you know, teamwork is such a big part of everything. And then also just being a good listener and making sure that you're hearing the concerns of all the different, you know, stakeholders or groups that you might be working with at any one time, and, you know, incorporating, you know, all of their needs into, you know, the package that you put forward, whether that's, you know, preparation for some kind of debate, or whether that's, you know, now when we engage on these hearings and, you know, put together the materials that we will then send over to the Hill. So those are important skills as well.
Thank you.
I can read the next one. We can mark this as. Can you give us an example of policy development and implementation, e.g., what might a COVID-19 vaccine policy analysis or development look like?
So, I mean, there's all types of different policies. I mean, so I can give an example more directly that I worked on. You know, obviously there's legislation, but from the White House. So we worked on a presidential directive that focused on biosecurity, biodefense. So that's a process where, you know, it's interagency, all the different departments and agencies that have a role in this case, you know, biodefense and public health preparedness, from Department of Defense to Homeland Security to Health and Human Services. They gather through this interagency process. They lay out a strategic plan. What are the main issues that we want to address in this policy? What are the role, you know, kind of strategic priorities? What are the roles for each agency? What's the budgetary impact going to be? So that's why Office of Management Budget is part of that. So what are the implications? And so you, through a long process, potentially work through that directive. And so then it's approved. It goes all the way up through the principals of the, you know, the secretary and agent, you know, leads of those agencies. The White House agrees to it, it's approved and goes out. And then it has to be implemented. So each agency says, okay, I'm supposed to develop this, you know, surveillance program for biological threats, and here's the funding. So then they go out and do that. So, so each agency has a piece they then need to implement that can ideally continues to be coordinated through some kind of White House committee. So it brings back the agencies. Okay, CDC, what have you done to address this surveillance initiative? Department of Defense, what programs have you implemented? And so it's not a one time and it's done in that case, but you need to continue to review the implementation of that and how are the agencies ideally working together to implement that. So of course, there's all types of different policies, but that's just one example.
And to give you an example of sort of policy formulation at at the much higher kind of legislative level, where there's far less detail and typically involved. But I worked on a bill that never had a chance of becoming law. I guess we knew that at the beginning. But it was around on the issue of privacy, personal privacy with increased deployment of drone aircraft in our airspace. So this was in 2012, 2013. FAA was just opening the door to both commercial and civilian use of drone aircraft. So we went and learned, what is the FAA? What are the rules and regulations they have around where could drones be operated and where could they go? Had they thought at all about what kind of information might be collected on drones? If so, how long would that information be retained? Would there be anything personally identifiable? Would that be shared? Of course, FAA is not an information technology company. They're a don't let planes fly out of the sky company organization. So this hasn't been things that they were thinking about. In parallel, we had reached out to drone manufacturers. What are the kinds of applications and uses that you envision for these drone aircraft? And were there places where we felt that where we, again, this was one office's opinion, but where we felt the net harms from resulting privacy compromise exceeded the opportunities, either economic or otherwise, for societal good. So that was, I don't know, a month of 2 or 3 meetings a week related to that. And from that, we had some broad ideas of and some model systems. What were some parallel things where people did a good job of dealing with sort of privacy compromising information. We looked at cases of historical cases of fixed video recordings and how is that information retained and used, and under what conditions can it be used by law enforcement, things like that. Anyway, from that, we crafted a very high level bill, which frankly sort of says, hey, Federal Aviation Administration, here are some things that you need to include when you move forward with authorizing the operation of drone aircraft in the United States. And I think the list of things that should be included and the list of questions that should be asked that we spent a lot of time coming up with, I think in that bill were quite good. I think if those questions were answered well, you could wind up in a regulatory regime where you minimally interfered with legitimate commercial uses of drone aircraft and dramatically decreased potential for compromising privacy as a result of it. But none of that had the details about exactly what you would do and how you would do it and things like that. That was all punted to the federal agency to work out those details. At the legislative side, it's mostly asking the questions and setting what the detailed policy needs to achieve.
Although it's gotten more detailed over the years, I'll say.
Yeah.
We'll move on.
So what folks didn't quite get there is there's a healthy tension, I think, between legislative folks in Congress and folks that both interact with legislators and policymakers in the federal agencies, and that is an integral aspect of the check and balances system of the United States government. And so, I mean, that little bit of tension that you just saw right there, that's indicative. That's us each speaking up for our old bosses and our old agencies. Yeah.
Well, thank you. Well, next question that we also have. So I think all of you have kind of alluded to how you got into science policy in certain positions, but some of the people in the panel are kind of curious about if you could go into a little bit more detail about how you really made that transition from grad school into your current position, and in terms of like interfacing with science policy and how much you felt like grad school prepared you for that.
I mean, I'll just say, you know, I did quite a bit of research, and I did end up, I applied for a AAAS fellowship, and I ended up getting the offer at FBI, so I didn't take it. But I think I talked to quite a few current and former AAAS fellows, talked to people involved in PMF program at the time, you know, so, you know, from different departments and agencies. So I think it was critical to really engage with a lot of those people doing different types of fellowships and across different agencies. You know, I think the graduate program wasn't, you know, my mentor was very supportive, but didn't have any experience in science policy per se. So I think that's probably true for most people. So you know, I think a lot of it is, for me, was doing that research and working with people, you know, finding more about people in the kind of role that I was interested in. So I think that's a critical piece of it.
Yeah, and for me, I mentioned that I attended that global health and biological security seminar series. I also went to a week-long boot camp when I was a graduate student that was all about public policy and biological threats. That was through a program by the IGCC. I'm not sure that they're still running that program anymore. So that kind of, you know, helped me familiarize myself with the space. I ended up doing a couple postdocs that were more research focused, but yeah, I was involved professionally with, you know, postdoc society. I helped run it 1 year during one of my postdocs, and I also helped start a program that helped introduce graduate students and postdocs to non-academic positions. And so I was kind of always doing these things on the side. And then, you know, during the 2016 election cycle, that really kind of set me on more of an activism path. And eventually I started working on the campaign full time because some things happened where the district I worked in was a bit of a long shot. And so our candidate was kind of having trouble attracting like really seasoned campaign staff. So he just kind of took a shot on a bunch of us who didn't have a lot of experience, but just worked really hard and, you know, could pick stuff up. And then you're transitioning from the campaign, which we didn't win the election, to the current job. It was actually based on networking. So a buddy of mine from graduate school is the president of FAS. And so, you know, we were talking and things worked out that I could start down here in DC.
Well, thank you. I know the panel is supposed to end at 7. Do you have time for 1 or 2 more questions before we end everything? Thank you.
Sure.
I can ask the next question. It's from Sandra Foma, and she's asking, please advise on opportunities available for international graduate students. I'm from South Africa.
Sarah, I'll be honest. One, I just don't know as much. But for example, this AAAS program, there are nations around the world that are starting to replicate it. Canada recently implemented a smaller scale program with a similar structure. Something not too dissimilar from it has existed in Germany for a number of years. I don't know about South Africa specifically. I'll also say some of these opportunities are not quite as citizenship dependent as you might think. It varies. For example, some of those AAAS fellowships do require U.S. citizenship or permanent residency, but some don't. I think it's a minority that don't, but some don't. Beyond that, the jobs in science policy rather than the fellowships in science policy are truly open to everyone. For example, working in sort of science advocacy organizations, the Union of Concerned Scientists, or places like that, they have a quite international employee base, in part because, you know, Union of Concerned Scientists views themselves as a globally active policy organization, and so that international base is important for their mission. But I will be honest, I am aware of, and I think there exist more opportunities for folks, for PhD level scientists, if you're a US citizen or permanent resident, at least currently.
Yeah, I would just add, I think, as Chris pointed out, the scientific societies along different disease areas, disciplines, the national academies, I think a number of organizations that do really interesting and impactful work on science policy on a range of issues. That's less of a, would be very open to that.
Yeah, it's just this AAAS fellowship, which I've talked about, and Scott mentioned, it really is an excellent on-ramp into this science policy world for someone that already has a PhD. And that, unfortunately, at least the majority of those fellowships are restricted to US citizens, permanent residents, but anyone can apply for a job.
Chris, do you know about the National Academies programs?
The Mirzayan Fellowship? Yeah, I think that one's restricted as well.
Is it? Okay, yeah. I wasn't sure.
Yeah, and a good way to start to get familiar with some of these opportunities as they come up, there's a newsletter that's done by, it's called the AIP FYI Science Policy Newsletter. That's a good one to subscribe to. There's a Monday email in particular that summarizes a number of science policy issues, and then also has a few different career opportunities toward the bottom. So that'll help kind of give a sense of what's out there and what could be attractive to you.
Thank you. Just to quickly chime in, for anyone that's a current member or thinking about joining your SPI, things like this, questions like these, we would love to help address and navigate and learn, educate ourselves about. So make sure you join our listserv and kind of let us know what you want to hear more about the future. And maybe we can help people like Sandra navigate these kind of questions and situations that want to join science policy but aren't a citizen in America. Sorry, just wanted to do a quick plug. I think we'll finish up with one last question, and then we'll let everyone go back to their evenings. So I think something really important is we've talked about in this panel a lot of things that have happened post-grad or kind of just like 1 week things. And most of them have been more policy-based, and we've touched upon the concept of advocating for science. And so one of the questions someone has is, what advice do you have to start the process of advocating for science-based policies while we're in school, especially since a lot of us don't have much exposure to that?
So I think that one thing you could certainly do is start with your local representatives, the people who represent you at the federal, state, and local level. My boss worked as a Senate staffer for 10 years or so, and he just really drills me all the time with make sure that you're recognizing the priorities of the people that you're going to be talking to, and make sure that what you're advocating for is somehow aligned with at least one or two of those priorities, so that they it's very clear how what you're advocating for can help them move toward their goals or better serve their constituents. So making sure you're very aware of where the people that you're advocating to stand on the issues and what their priorities are.
I would just add, whatever discipline or you're involved in, the society, if you're a member, whether it's in microbiology or toxicology or neurology, rare diseases, they have, as a member of that organization, there's probably opportunities to work with that society to help participate in some of their advocacy efforts. I imagine there's opportunities to explore there. I know through some of the annual meetings, they do their Capitol Hill days, but I think even on specific policy issues, there might be opportunities to get involved. The university has the government relations office that I think's an opportunity too to work with them to get involved in particular issues. And then beyond advocacy, I mean, there's also opportunities to do more policy analysis and work on policy analysis issues and contribute to and publish some of that work.
Yeah, I think the opportunity to, to go on a Hill visit day with your scientific society is a sort of a classic graduate student introduction to science advocacy. Just watch out for they'll give you a couple hours of training before they send you loose on the Hill. If anybody tells you to advocate for funding in your narrow discipline, tell them you heard from Chris Schaffer that that's not what to do. And instead, you're here to advocate for funding for capital S science.
Cool. Thank you, everyone. Thank you for all of you that stayed to the end. Thank you to our three panelists for taking the time and sharing with us your knowledge. I just want to quickly note, after 5 minutes in, someone messaged me asking if we'd be recording, so I started recording. I will see how feasible this file will be able to share with all of you in case you didn't catch something or you joined late. And I'll try to make sure that only those of you that showed up will get access. We'll also do our best to kind of allocate some of the resources shared by Chris, Scott, and Mike in terms of websites, the AAAS fellowships and other things, and email those out to all of you. And the easiest way to do that is, as King mentioned in the chat, please email us. I do have all your emails from the registration, but just to make sure we don't lose you, you could directly email us that you want to join or be a part of our listserv. And we do have a Twitter account that King is in charge of posting cool, fun stuff on. So that's with that. Thank you, everyone, and have a good night.
Thanks very much.
Thank you.
Enjoy this.
Take care, everyone.
Everyone, bye.
Yeah.